All right, can everybody hear me? All right, so does anybody have any questions? You can feel free to put it in the chat or unmute yourself and talk.
Any questions?
Let's see what the sign is now. I don't remember if I finished setting myself up with WebAssign.
There's a. I think there's a.
Just use Cengage. Been able to get to WebAssign from there. You can get the textbook. Oh, shoot.
That should work too.
I'm sorry about this. Actually, can somebody just like put in the chat if they have it around them? All right, that works.
So. Is it only A and B? Studying that, just set up share screen and show the.
Okay.
Computer.
Just, I don't remember the formula. Yeah, we got it. Isn't it there? Okay. So yes, that. Why am I blanking on this? I know this is fairly straightforward,
Yeah.
but I'm just blanking on it.
So you need to set up the differential equation using the expected, or not the expected, the slot formula.
Yeah, because I'm not seeing the formula in the book. Because I'm trying to,
Just remember that y is temperature in this case.
yeah. So you
I
get,
think we're good on the sharing screen, by the way.
yeah, you can stop sharing. So this is the general form. Can't I read that well, or should I zoom in more? I feel like I should zoom in more. There we go. Is that in focus? There we go.
Just say that for-
All right, so they say the surrounding temperature equal to 20 degrees. Degrees Celsius, and they, at when T is equal, or well, I guess it's Y. This should be Y. When Y is equal to 70, dy dt is equal to 1 degree Celsius. So you use these two to solve for your K value. Is it cooling at a rate? It should be -1 since it's cooling at a rate of 1 degree Celsius equal to -K. Is that right? Yeah, that should be right. K times 70 minus 20. 70 minus 20 is 50. Ooh, 50. And so then -1 is equal to -K times that. That's just. Then you divide by -50, so K is equal to 1/50. So then your dy t is equal to -1/50 times y minus 20. Does that kind of make sense, or so? So does that answer your question, or is there something specific you want me to go over with that, or okay?
Or we just graph it.
Okay. So they kind of make it harder just So like they give you the basics and then you kind of learn how to apply it in the homework, and then they make it harder to kind of stretch your brain and really make you think, which isn't fun, but it kind of works. I don't know if I've seen that before.
That question.
Making a program on your calculator.
Wait, maybe what? Oh. Oh, I haven't seen that either. Do you know what question code that is? Might be able to look it up. So that's, do you have like it would be like 9 point, oh, okay, thank you. 9 point. I'm hoping this works. Maybe I don't know. Trying to search for it. Just think of that.
Oh, is that for like Euler's method? And so then they want you to like go far out. Yeah. Trying to remember what I did. No, actually, I don't know if I got any of those kind of questions going out to 1,000.
Yeah, I can't find it.
You weren't able to find it?
No.
Okay.
Our particular or SMH doesn't have any courses listed.
Yeah, that's a problem I ran into last week.
That's part.
Um,
The
Okay,
last.
so that's the same question. Oh, there is more. Okay. So use the Euler method. Step H is equal to 2 minutes to estimate the temperature of coffee after 10 minutes.
C.
Okay.
So you can use the concept that you still have.
Yeah, I'm gonna stick with my same numbers just so, just because I already have the numbers. So with Euler's method, I like doing setting up a table where you have, well, in this case, it'd be t, and you have your y, and you have your dy dt. And And you also have your, I guess you have your step here. So your step is always 2 minutes. You start off with 0, then 2, 4, 6, 8, and then 10. So you know at the start your temperature should be 95, right? That's what it was. At the start, your temperature is 95 degrees Celsius. So if you, so then you're plugging in your y into there. So then you have -1/50. Oh, that's 50 times 90 minus, or 95 minus 20.
I'll see you to fix your paper.
Yes, I do. So that is equal to negative 1.25, 1.5, 1.5. And so this is your slope, that's your dy dt. Then you want to multiply that by your step, because your step is equal to dt. And so you want to multiply it by your step. You multiply that by 2 to get 3. Get 3 degrees. It'd be negative, negative 3 degrees. And so now this is equal to your dy. And so then you're changing y from 0 to 2 is estimated to be -3 degrees. So then you do 95 minus 3. So your next one will be 92 degrees. So then you do the same thing. You plug in 92 here. So then it's 92 minus 20 is 72. Divided by -50. So your dy dt is -1.44. I'm gonna add another. So this is your dy. So then you multiply by 2 again because that's your step. To get your dy. So 1.44 times 2 is -2.88. Then you do 92 minus 2.88. Get 89.12. And oh boy, I'm not very good at staying within lines. So we'll just move these down so it gets less confusing. 4 and then 6 is going to go down there, and then 8 and then 10. So now you're at 4, so you plug in 89.12 in there, so it's minus 20, 69.12 divided by 50. So now this is -1.3824. Multiply that by 2. Get -2.7648. This is fairly important to keep decimal places. I don't know how many to recommend keeping.
Yeah, normally you don't end up with so many decimal places.
Yeah, I would keep as many as you can for a while. Well, if it gets to the point where it's like, I'd say maybe 5+ decimal places. But if you're doing it on a calculator, then you should be able to just keep it. And that's what I'd recommend, is just using calculator. And so then you just keep going through and through.
Put the main Lewis method equation in chat.
Yeah. Oh, so you just need the form. Yeah.
Yeah, that's the best I can type it out using.
So yeah, so the basic formula is
Like that.
so this is basically your nth term, which is like, so in this case, your fourth term, your yn 89.12 is equal to your previous one, which would be 92 degrees, plus your h, which is your step, times, wait, is that right?
So it would be the
Yeah.
derivative.
Yeah, and so f is equal to y prime. So yeah, so h is your step times your dy dt. And so you plug in, and then this is telling you what you plug in. So you plug in your previous t and your previous y. In this case, your dy dt doesn't have any t, so you can, like, you never plug in any t. So in that case, with this wouldn't be a factor. So then you're just plugging in whatever the previous y was. So you saw here, we plugged in 92 here. So then it was 92 minus 20 divided by negative 50. And so that was this part right here. And then your h in this case is equal to 2. Does that kind of answer your question? Oh, moves. So like you're confused about like what this part is? Okay, you're this actually. And then at least for this continuing this problem, you just do the same thing over and over again, which is very annoying, but which is why, like, if you did make a calculator program for it, then it can kind of take the repetition out of it.
For these problems, it's helpful to store variables, like just storing each answer as x, and then you can just keep plugging in that. And it will eventually self-correct a little easier. There's some ways to get around it with most calculators. I know, I think most TIs, you can save a function and then take the derivative of that function and call it inside of your workspace. I might be wrong about that, but I think. Last problem, one more question. Well,
Yeah, can you either share your screen or I think you were the one that sent a picture. That works too. Okay.
this is circuits.
So what I generally look for. So we have R dq dt plus 1 over CQ equal to E of t. So if you look at, so your question was how to make I'm a little confused about what your question, like what you're asking.
So they're trying to figure out how to find the current. Is the Q over dt is the change in shard, change in time, which is correct.
Yeah. So it seems like this. So it seems like, is there more to this question, or is it just? Yeah, there's more to the question. What is yeah. So pretty much how they're kind of having you look at this is they're having you draw the vector field first, or direction field first. And so you're just, I think the best way to answer this. I don't like how they wrote this question either.
To remember circuits.
So give R is equal to 10. C is equal to 0.1. And V. Oh, E is the voltage. So
Yeah, that's almost,
E is equal to 90 volts.
that's just always true.
Yeah. So then if you're plugging in values, you get 10 dq dt plus 1 over 1 over 10. So that just becomes 10.
Then Q is a force variable as well.
Q is equal to 90. So I think what I'm looking at is, since you're looking at the slope field or direction field, you can, I guess that wouldn't, I guess it eliminates two of the options. So you can kind of see there's like a dead zone where the slope is 0. So if you figure out where the slope is 0, that gets rid of two of your choices, and so then that leaves you with two of them. So if you divide by 10, and you have the QDT. Actually, I guess you could just say, yeah, if you just say when your slope is equal to 0, then you plug in 0 there. So 10Q is equal to 90. So Q is equal to 9. So when the slope is 0, or Q is equal to 9 when the slope is 0. So then that narrows it down to your top left and top right options, or not top left, top left and bottom right options. And you can kind of see that one of the values, or one of them, it approaches, like everything kind of converges to 9. And then the other one, all of them kind of diverge to 9. So what you can do is you can plug in a value like greater than 9. So like I'd say like plugging in 10. So if you say Q is equal to 10, 10 dQ dt equal to 10, oh, that's not right. Plus 10 times 10 is equal to 90. So it's 90 minus 100. So 10 dQ dt, I switched to lowercase q. 10 dQ dt equal to negative 10. That means dQ dt is equal to negative 1. So that indicates that above 9, the slope is negative. If you want, you can confirm by doing a value less than 10. So like you can do Q is equal to 8. That's 10 dQ. 10 dQ dt equal to 10 times 8. Oh, not plus, not equals. That's not bad. Plus 10 times 8 is equal to 90. And so this is 80, so it's 90 minus 80. So then you get 10 dQ dt is equal to 10. So then dQ dt equal to 1. So from plugging those in, you can see when Q is less than 9, the value seems to be positive. When Q is greater than 9, dQ dt appears to be negative. So then, like looking at your graphs, that question relating to, yeah. So then looking at the graph, you can see that the top left one, it's negative above 9 and positive below 9. So that would be your choice. Was that the only part of the question that you wanted answered, or did you want more of the question answered? That's why I'm looking at the rest of the problem. Does anybody else have any questions, or do you guys also want the rest of the problem gone over? Yeah, I'm just what's the limiting factor? Is that? Is that? Is that just 9? Is the limiting factor just 9? Or is that?
What would be the fine? Well, it's the charging.
Equal to be. Yeah, the limiting factor should be 9 because it's, if you like looking at the vector field, so I'll just rough sketch. It's 0 at 9. amazing vector field. Like no matter where you go, like if you start here, you're gonna go to 9. And so then the limiting factor is just wherever like you're gonna go, kind of. That's a terrible description, but yeah. Is there a better way I can describe it? So like in the book it says all solutions approach the value, and so then well, I guess limiting factor is you're taking the limit as t approaches infinity, and so as you go into infinity you're going to end up at 9. So then and then that kind of answers the next part. Since there is a limiting factor, there is an equilibrium, like it, like because all the vector fields point to 9, then 9 is the equilibrium of position. So then there is, or equilibrium solution. So then there is an equilibrium solution. And then the last part, just based off the location, you know, it approaches 9. So then it has to be the bottom right choice. And then, yeah, and then steps or the last part is very similar to, okay, cool. It's very similar to the other problem we went over. Sweet. Does anybody have any other questions? Leave that up. If nobody has any specific questions, are there any like concepts that you guys are kind of like uncertain about that you've like gone over again or like reviewed or something? Oh, down. Is that good? So arc length, is that what you're asking about? Let's see if we can find a good problem for that. All right. Are you good with the paper now, Steve? Okay, cool. Okay. So just going over the basic formula. So the basic formula is equal to integral from a to b of the square root of 1 plus dy dx squared dx. And this can also be written as 1 plus dx dy squared dy. So those are just two forms. So like if you have a formula where it's easier to get dx dy, then you can use this. Or another way, if your bounds are in like the y-axis, or if your bounds are in the x-axis, that can also determine which one you use. Is there like a specific example you're looking for, like something with like trig, or something with like logs or exponents, or like something in particular, or just in general? In general. So just this one looks fun. So if you have, this is problem number 12 in the book, if anybody wants to look it up later. So it's x is equal to y to the fourth over 8 plus 1 over 4 y squared. And it's 1 less than or equal to y is less than or equal to 2. So the first thing I see is the bounds are on the y-axis. So it's likely that I want to use this formula. And so it also helps that it's x is equal to. So then when you can take the derivative, so it can be x prime, which is equal to dx dy. And so now you're taking derivative of x with respect to y. And so then you just treat y like it's an x. So you do the derivative of y to the fourth, so you bring down the 4, so that's y cubed over 4 plus this I'm going to rewrite at, this one can be rewritten as 1/4 y to the negative 2. So then you bring down negative 2 and subtract 1, so that's y to the negative third. It's equivalent of 1/2 y cubed, or y cubed minus 1/2 y to the negative third. So solve for dy dx and for dx dy. Excuse me, I'm gonna drink some water real quick. Not used to talking for this long. Okay. So y cubed minus 1/2 y to the negative third. So then you're gonna plug this into your formula. So it's dx dy squared. So L is equal to integral from a to b, your lower and upper. So that's 1 to 2 of the square root of 1 plus 1/2 y cubed minus 1/2 y to the negative third, all squared. Dy. This is pretty much just algebra trying to get it into a form that you can integrate, which is I don't want to do that. So you can pull out. So there's 1/2 in each of these, so you can pull that out and square it. That's the square root of 1 + 1/4. And so then you're squaring 1 or y cubed minus y to the -3rd squared. So you'd FOIL that. That's showing up a little down. -3rd times y cubed. So it's y cubed times y cubed, which is multiply, so you add. Yeah, you add. Yeah. Right? Am I doing this right? Yeah.
So what you think? So y to the 6.
Yes, that's right. Okay. Yeah. So y to the 6. And then times y to the -3rd. So 3 minus 3 is just 1. And you do that twice. So then it's minus 2y. And then it's multiply.
Like you have 1 cubed and 1 to the -3rd, right? So it should be 1 to 0.
I can do math. -2. And then 3, so then it's plus y to the -6. I feel like I chose a bad problem.
No, this is actually a nice problem. Like I said, it's simplifying,
Yeah.
combining like terms.
So the next part is simplifying, as Keaton said. So then you can multiply the 1/4 back out. So first thing I see is 1/4 times -1/2 is, or -2 is -1/2. So then it's 1 minus 1/2. So it's the square root of 1/4 y to the 6.
These are my favorite working problems.
These are not apparently, because I'm blanking hard. -6. Oh, is this where you pull something out and then?
You don't have to pull something out, kind of pull up a little bit. If you recognize, so remember that's +1/2, right?
Oh, yes. Oh, yeah.
You see what you do now.
And then, because then that just becomes, right?
Yep.
Yeah.
Of course, that's the one.
Yeah. Mm. 1/2. Yeah. Oh, yeah, because you pull out the 1, or yeah. Or you pull out 1/4, wouldn't you? Yeah, 1/4. So it'd be 1/4.
And that's all in the square.
Yeah. Did that jump make sense to anybody, or should I kind of show the steps a little more?
It'd probably help if you showed what the form of the original square is, because it's 1/4 y to the 6th minus 1/2 plus 1/4 y to the -6th,
Yeah.
which the new form that we have is just plus 1/2 instead.
Yeah.
So you notice that the parentheses go from y cubed plus y to the -3rd from the y cubed minus y to the -3rd.
Yeah. So I'm gonna rewrite this with pulling out the 1/4. So it's the square root of 1/4 times y to the 6. So y to the 6 plus 2 plus y to the -6. So if you look at this, it's the exact same, except this positive is switched to, or this negative right here is switched to a positive. And so then, and this -2 was caused by the minus y to the -3rd. So then when you see that, it switches to a plus. When you do y cubed plus y to the -3 squared ends up being a +2, since it still ends up y cubed times y -3 times y cubed times y -3. So then it just ends up being 2. So that's how we got from there to there. So then, since all this is under a square root, which probably include that, the square root of 1/4, and so when you have two things multiplied together, you can split it into 2 square roots. So you can have square root of 1/4. It's a lot harder in practice. Times the square root of 1/3 plus y to the -3 squared. So square root of 1/4 is just 1/2. And the square root of a square just cancels out. And you just end up with y cubed plus y to the -3rd dy. So then you can pull the 1/2 out and go from 1 to 2 of y cubed plus y to the -3 dy. And this is just using power rule. So it'd be 1/2 times y to the 4th over 4 minus 2, wait, oh, that's wrong. Minus y to the -2 over 2. And that all goes from 1 to 2. Which is, yeah, 1/2 times 2 to the 4th over 4 minus 1 over 2 times 2 squared minus 1/2 times 1/4 minus 1/2. Did that problem make sense? Is there any part of it that you want me to go over? Any part you need me to like show more work on, or did that kind of make sense? Cool. Yeah, like once I like remembered that this was a thing, like this, like Keaton, this is one of my favorite ones, just because it's like just a simple little thing. It switches from a positive to a negative, and then like once you see that, then it's like, oh, you can see that, and then it's squared. The squares cancel out with the square root, and it just kind of turns out nice. But yeah. Yep. All right. I guess time is pretty much up.
Switching over to the next hour's group.
Yeah, so our review session is finishing up now. We'll sign out, and then in a couple minutes, the next Calc 2 review session should be up and ready to ask if you have any more questions. So yeah, thank you guys for showing up, and have a good rest of your day.